The rapid advancement of large language models, like GPT and others in the generative AI space, has sparked a new wave of discussions. While software engineers have long been seen as the first professionals affected by the automation capabilities of LLMs, recent developments suggest that AI researchers themselves may soon feel the heat. Here's why this trend is gaining momentum and what it might mean for the field of artificial intelligence. LLMs as AI research aids. LLMs have already proven their ability to generate research ideas, propose solutions to complex problems, and even write academic papers. For instance, tools like ChatGPT and Bard can generate hypotheses based on existing literature, suggest novel approaches to data modeling or algorithm design, code new algorithms in various programming languages without requiring extensive human intervention. This ability to ideate and implement foundational research is transforming how AI researchers approach their work. Automating research processes. AI research involves numerous repetitive tasks like data preprocessing, experiment tracking, hyperparameter tuning. Now, tools powered by LLMs can perform these tasks faster and with fewer errors. Open-source frameworks like Hugging Face and AutoML platforms are incorporating LLM capabilities, further automating traditionally human-intensive processes. Generative AI in research writing. The publication process is a cornerstone of AI research. With LLMs generating draft papers, literature reviews, and summaries, researchers are saving substantial time. This is especially impactful in academia, where publishing frequency is tied to career progression. However, this raises ethical concerns regarding the originality and integrity of AI-generated content. Democratizing knowledge. Traditionally, AI research required years of study and access to resources like journals, datasets, and computational power. LLMs have changed this landscape by explaining complex topics in layman's terms, providing on-demand tutoring in advanced subjects, creating simulations or experiments that were previously resource-intensive. This democratization is enabling enthusiasts and junior researchers to compete with experienced professionals. Challenging traditional roles. Some traditional roles of AI researchers, such as developing new architectures or optimizing algorithms, are being disrupted. LLMs trained on cutting-edge datasets can now propose novel neural network architectures, optimize models with minimal human input, perform meta-analyses to identify gaps in the current research landscape. Collaboration, not replacement. While the capabilities of LLMs are impressive, they are not without limitations. Lack of creativity. True innovation often requires a depth of domain-specific intuition that LLMs can't replicate. Ethical reasoning. Designing responsible AI involves nuanced moral and societal considerations beyond an LLM's current scope. Contextual understanding. LLMs may struggle with tasks that require deep contextual insights. LLMs are more likely to augment the work of AI researchers rather than completely replace them. Future implications. As LLMs continue to evolve, the skill set required for AI research is likely to shift. Researchers may need to focus more on interpreting and validating AI-generated outputs, develop expertise in fields like ethics, regulation, and cross-disciplinary applications, adapt to a more competitive landscape where access to LLMs levels the playing field. The rise of LLMs could lead to a significant redefinition of what it means to be an AI researcher, making the field simultaneously more accessible and more challenging. Redefining AI research methodology. The traditional methodology of AI research involves multiple stages: ideation, experimentation, evaluation, and dissemination. LLMs are disrupting each of these phases. Ideation. LLMs like GPT can act as brainstorming partners, suggesting new research directions or methodologies based on a corpus of existing research. For instance, if an AI researcher is exploring reinforcement learning, the LLM can propose hybrid approaches that combine elements from reinforcement learning and other domains like transfer learning or unsupervised learning. Experimentation. LLMs equipped with programming and data analysis capabilities can implement simulations and run experiments autonomously. Platforms like OpenAI Codex or GitHub Copilot assist researchers in coding experiments with minimal errors, reducing development time and improving productivity. Breaking down barriers in specialized fields. One of the significant advantages of LLMs is their ability to traverse multiple disciplines, and synthesize knowledge across fields. For instance, interdisciplinary research. LLMs can integrate concepts from unrelated fields like quantum computing and biology to propose innovative AI applications. Language barriers. LLMs trained in multiple languages democratize access to research by translating findings, enabling global collaboration. Access to obscure knowledge. By parsing older, less cited papers, LLMs can uncover hidden gems in the literature that human researchers might overlook. This democratization could lead to a surge of breakthroughs from underrepresented regions and smaller institutions. Ethical concerns and misuse risks. While LLMs provide substantial benefits, they also introduce risks and ethical challenges, particularly in the context of AI research. Plagiarism. LLMs trained on publicly available research might unknowingly replicate or slightly reword existing findings, leading to concerns about originality and intellectual property rights. Fake research. The ability to generate realistic but inaccurate research papers could flood the academic community with misleading information, undermining trust. Bias amplification. If LLMs are trained on biased datasets, their suggestions for research directions or model improvements might inadvertently reinforce existing prejudices in AI systems. Regulations and ethical frameworks will be necessary to ensure that LLMs are used responsibly in research contexts. Job transformation and role evolution. The potential for LLMs to automate large portions of the AI research process is prompting discussions about job displacement versus transformation. While it's true that certain roles may become redundant, the overall landscape is likely to evolve rather than contract. Here's how. Emerging roles. New roles will focus on interpreting and guiding LLM outputs, ensuring ethical compliance, and optimizing the interplay between human creativity and machine efficiency. Collaborative environments. AI researchers might work more closely with LLM-powered systems, treating them as junior collaborators rather than mere tools. Upskilling needs. Researchers will need to acquire new skills, particularly in understanding how LLMs function, troubleshooting their limitations, and leveraging their strengths. The shift mirrors transitions seen in other industries during technological revolutions: displacement for some, opportunity for others. Accelerating AI democratization. One of the most profound implications of LLMs is their potential to democratize AI research. Here's how this could play out. Lowering the entry barrier. Aspiring researchers with minimal resources can use LLMs to access knowledge, develop models, and publish findings without needing large-scale institutional backing. Equitable access. Tools like ChatGPT and AutoML are increasingly available at low or no cost, empowering individuals from diverse socioeconomic backgrounds. Crowdsourced research. Platforms integrating LLMs may enable global research collaborations, allowing experts and amateurs to co-create solutions. This democratization could significantly expand the talent pool and lead to diverse perspectives that enrich the field.